Welcome to JCB EduBuild Solutions. As you prepare for your licensure examination, we will be your guides through the exact mechanical verification protocols mandated by the revised National Plumbing Code. When you look at a finished commercial building, the structural shell hides thousands of meters of complex piping. On blueprints, this network is an idealized concept. It is pure theory. A plumbing system design remains only a theory until it is physically stressed and proven intact. Every concealed joint and fitting represents a potential point of failure. If those connections yield under mechanical load, the resulting leaks threaten the structural integrity of the building and the safety of its occupants. Because of this risk, the testing protocols outlined in Chapter 5 of the Code are absolute requirements. They provide the definitive empirical proof required to validate a system's safety before a building can be inhabited. This brings us to the prime directive of plumbing inspection, the strict prohibition on covering unverified work. Section 501.1.8 is explicit. No plumbing system shall be covered or put into use until inspected, tested, and approved. Furthermore, Section 501.1.3 states the master plumber must ensure the work withstands these tests and provide all testing equipment. Physical testing serves as a strict chronological gatekeeper. You cannot advance to the drywall or finishing phases until this empirical proof is secured. Before physical pressure can be applied to the pipes, you must clear the administrative workflow required to initiate a test. The Code establishes a precise numerical parameter for scheduling. Under Section 501.1.2, you must notify the administrative authority that the work is ready for inspection not less than 3 days before the intended test. A technically flawless pressure test cannot result in a certificate of approval if the master plumber fails to satisfy this 3-day notification window. Once the inspector is on site, you must verify the drainage, waste, and vent systems. The Code permits 2 testing media for this process: water or air. This diagram shows a DWV water test. The system is filled to overflow, requiring exactly a 3-meter head of water for adequate static pressure. Target pressure is just the first step. The water must remain entirely static for 15 minutes, proving zero leakage. If a water test is impractical, the alternative method utilizes an air compressor. The air test requires forcing air into the system until there is a uniform gauge pressure of 34.5 kilopascals. This is sufficient to balance a column of mercury, exactly 254 millimeters in height. Just like the water test, this internal pressure must be held without the introduction of additional air for a minimum of 15 minutes. Whether utilizing the physical weight of a 3-meter water column or the uniform outward pressure of 34.5 kilopascals of air, the piping must sustain the applied stress flawlessly for an entire 15 minutes to definitively prove its structural integrity. Drainage relies on gravity, but potable water supply systems operate under constant internal pressure. Consequently, they demand significantly higher testing thresholds. This shows a potable water line under stress. The system must be proven tight under a water pressure not less than its working pressure, plus 50%. If using air, a static pressure of 344.5 kilopascals is substituted. Either method requires 15 minutes without leaking. Different subsystems dictate specific workflows. For building sewers, Section 501.2.5 specifies plugging the end and filling it with water from the lowest to highest point. Similarly, Section 501.2.10 requires shower receptors tested by filling with water precisely to the rough threshold. Testing protocols are not uniform across a building. The applied pressure and methodology must scale mathematically relative to the intended function and specific risk profile of each subsystem. Once construction concludes and the building enters its operational life cycle, the requirement for mechanical verification does not end. If an existing plumbing system is suspected of degrading over time, Section 501.2.7 mandates the use of an air test to verify the tightness condition of the drainage or plumbing network. When a system fails and creates a sanitary hazard, the property owner bears the legal obligation. Section 504 requires the owner to install additional facilities or make necessary alterations to alleviate any dangerous or insanitary conditions. The code establishes system verification as a permanent obligation to public health that persists long after the initial construction is complete. This infographic isolates the 4 exact numerical metrics you must memorize for your licensure examination: the 3-day advance notice, the 15-minute hold time, the 3-meter head for DWV, and the working pressure plus 50% for supply lines. Applying these exact numerical parameters represents the professional standard for every registered master plumber.